So in this session, we'll discuss how to clean the data and work through all the steps of cleaning the data. And it's a relatively critical step in the analysis and probably one of the more intensive ones. So we're actually going to go through a couple steps in here and show you a couple iterations and what different levers do. So before we dive into this, I'm actually going to switch the project that we include in here because we actually want to work with messy data. And for simplicity, I'm going to pull in the West Balmville data, and we'll show you where that is located. And we'll leave all the other settings intact because really what we care about here is the data cleaning. We don't care about the financials and different aspects here. So I'm going to go to the load data folder and delete the current data, which is RDRJ. And you'll notice that in the model folder itself, you are going to have wherever you place it, you're going to have a folder located in there that has example data. So if we look at the model, here you see a folder called example data. And we're simply going to open up the West Balmville interval data, which is directly from the SCADA system. It's formatted in the same format as we drop it into the model. Just copy, Control-C, and paste. And this will be the data that we work with. Again, we're just picking this example because we know it's a messy one. And in this case, since we're talking about data cleaning, we want to actually work with messy data. So first step that we have included that we have to load the model inputs. That takes a couple minutes, and it's going to go through it and pull that information. The three key drivers when it comes to data cleaning are going to be the trend sensitivity data cleaning in the input folder at the row 31, which is the data cleaning or shaving sensitivity, and the number of flags that lead to exclusions. We'll walk through what each of those means, but the main thing is these are really the levers that allow you to control how you clean the data. And they're really relatively intuitive once you get a grasp of the data overall. So before we dive into that, let's take a look at, let's hit the clean data button. And prior to doing this, I'm going to actually change the number of exclusions to 3. And the reason for doing that is I know in advance that that's not going to capture the analysis, and we're going to go through a couple iterations and arrive at what is probably the best option for cleaning the data. So if we hit clean data at this point, what it's essentially doing, it's going into the background, pointing the information, and asking a series of questions that identify whether the data has some follows patterns or not. And it's creating flags for those. So the questions that it's asking are relatively simple. It's asking, do you follow the weather trend, or are you an outlier? Do you follow the daily trend, or are you an outlier? It does it for the peak as well as for the average daily load. It also is asking questions such as, is there a pattern that shows an outage, like there's a load drop that occurs, and basically the load comes back up a few hours later. And it will inquire as to whether there's user-defined exclusions. You notice here we have a component here that we included periods to exclude, and those are being excluded intentionally because they're user-defined exclusions. And lastly, it asks regarding whether or not you have a lot of leading zero values, whether they're leading values or values that are consistently 0. So it kind of works through all of that. It produces a whole bunch of plots, which you just saw pop up, and it essentially goes through and imports into the model. Here's the clean data with the reasons why the flags that it created and whether that particular observation that day was flagged as an exclusion. And it also imports all those charts so you can just view them directly in Excel and kind of sort through them. So now it's all done. Let's go take a look at what the data looks like. So if we look at the historical, the cleaning data graphs, we'll see a couple things at the top. One is that we define here, really here's how those flags are created. And we don't remove instances, days for exclusion unless there are multiple flags. And that's something that the user defines. So essentially, if you have one yellow flag. Okay, that's an issue. If you have three of them or four of them, there's probably something really going on, and we likely need to go ahead and remove that day. And there's a number of charts that actually walk through and show you here's the final results of the final exclusions, and then walk step by step and say here's what flag led to the exclusions. So you can actually walk systematically and say, was it the weather pattern that led to exclusion? Was it the user-defined exclusion that led to it? Was it the daily trend, etc.? So high level, these are the high-level final exclusions. So conveniently, the data points that are kept in are the blue ones, and the ones that are removed are essentially the orange ones. And we can see a number of things going on here. First, we see that we have excluded a substantial most of the values that are basically outliers. We also have some exclusions that we should probably keep in. And we'll talk a little bit more about that down the line. Then subsequently, we see that the exclusions that we have are in terms of a time trend. So you can see there's a cluster right here that was excluded. And we'll go back and take a look at that. And there's another cluster right here that was excluded as well. These are probably done erroneously. The remainder are done correctly in terms of the exclusions. Then we start diving into here's the actual flags of the exclusions. The first question we ask is the low patterns deviate substantially from the weather trend. And just that alone seems to capture most of the outliers out here, which appear to be what is effectively a load transfer. And likely a seasonal one, and you can kind of see that in the time trend when we look at it overall. We ask the same question with daily average demand. It just captures a few different values overall. The daily peak demand trend doesn't capture as many of these outline observations. So it actually leads to a couple exclusions that probably shouldn't be an exclusion. And it doesn't pick up what are essentially smaller transfers, such as this one, that weren't identified by the daily peak demand trend. So you can kind of see that happening overall in terms of the pattern. This doesn't fit the pattern. Then lastly, apologies, I hit the button by mistake. But the last one that we kind of dive into is we just group all three of these last ones together, quite simply because they are not that big of a deal. This is a user-defined exclusion. So that was actually something left over from the prior model that where we kind of exclude a set of days. We likely need to include these back in there. We also describe it whether there's zero missing values. We only see one, and outages, which I don't really see listed on here, at least not major ones. The outage algorithm only captures, outages that affect most of the customers at a location for a couple hours overall. So it doesn't capture the momentaries or the ones that only affect a few customers. So what we're going to do, given all of this, and before going back and look at this, we also have this tab called Clean Data, where we dumped out a lot of detailed information. And there's a couple components that kick in. One of them is we have the actual raw data. Then we have each of the different flags and whether it's occurring for a particular date and hour, and whether that observation was included or excluded and is going to be included or excluded in the historical load analysis and the forecasting. And then we also have, if needed, basically an estimate of the MVA with the gaps filled. So in cases where value was not excluded, they're identical. In cases where it was excluded, we go ahead and use models that run in the background to fill in those values. So this allows you to take a look at, for example, let's just look at all the excluded values. And you can see the date of each value, the hour of each value, what flags were violated that day, and whether that was excluded overall. So you can get an understanding as to the reason for the exclusion if you really want to focus on one particular instance. And you also have an estimate of, here's the estimated value to fill it in, which in some cases is the same as the actual value, but that's typically in cases where you have a user-defined exclusion, or in instances where that hour wasn't in question. It was really a couple other periods in that day where you need to fill that in. So that's basically the key feedback loop in terms of what data, how the data cleaning is working. But this is an iterative process, so you likely need to go forward with this and modify this. Number one, you probably want to get rid of that. Number two, we want to make sure that we have loaded up a setting where this is set at 2, because we know this will capture pretty much all of the issues. So if you load the input models, again, take a few seconds to run, and we'll go ahead and clean the data, and we'll see what the results look like. And after the data is cleaned, and this will probably capture more of it, we'll talk a little bit more about what this data cleaning and the shaving sensitivity means, and what the trend sensitivity means. In practice, the two most powerful data cleaning components are going to be the number of flags that lead to exclusion and the data cleaning sensitivity. The periods to exclude here, which are user defined, are basically just a catch-all in case the algorithm doesn't capture some of the key periods overall. So that loaded the data. Let's go ahead and hit clean data. And as you guys notice, the algorithms in the background take a while to run. Part of it is because it is data intensive, but the other aspect too is because we're essentially estimating a whole bunch of models to fill in those data gaps as well. And that just happens automatically and is included in that clean data tab, as soon as that, whenever you run the model. So we can see that a lot of these patterns are similar, and we don't no longer have those user-defined exclusions as the windows pop up. And these are the models that fill in the data gaps. And it should be wrapping up very shortly. So I'm just going to shift over and wait for it to finish, and we'll subsequently take a look at the results. And the exporting of the data takes a bit longer because there's a big copy paste coming back into this model. So that's likely what's taking a while. While we're waiting for this, it's useful to kind of think through what trend sensitivity and the data clean or shaving sensitivity look like. And overall, the best way to illustrate that is to actually look at some of the graphs. So if I were to look at, say, the weather trend, what the model is doing and the clean algorithms are doing is they're looking and identifying a trend. And the trend is essentially a moving average. So that's the trend sensitivity. And if you make that trend much more sensitive, those lines will get a lot more squiggly because they're reacting to whatever data points you have there. And that's actually most obvious when you look at the time trend graphs, where you want that sensitivity and you want things to move, but you want to pick up the general pattern overall. The other component is the shaving, or the data cleaning sensitivity. And what that basically means is we take a bandwidth around that particular line and shave all the observations that don't fit in within that bandwidth. So that's why these observations out here are excluded. They're really outside of the bandwidth, and we want to go ahead and limit it and say we want to include things that are only relatively follow the pattern. Now, the algorithms are iterative, because if you went ahead and ran it only one time, you would get a pattern, line pattern that would probably look cut somewhere through the middle because of all those observations below. So we ran that pattern once, and we estimate and basically say, well, these guys are really outliers, drop it, and we run it again, and then we run it a third time. And in doing that repeated times, it essentially starts to converge and saying, here's the actual pattern where the bulk of the data is at, and excludes the outline results. So that's the core concept behind the algorithms. Now that we've done that, let's go ahead and just take a look at what the results look like and whether we're satisfied with them. So at this stage, we have essentially identified, pretty much all of the outliers. We have a couple observations here in terms of the time trend that we want to pay attention to, and assess if they're legitimate. So you can see them on occasion popping up, and the bulk of the observations are being excluded. This mainly because they don't fit the weather pattern, but they seem relatively good. So this is a pretty good outcome. It's acceptable. You can look at trying to fine tune it just a little bit further, but this will be passable in that we're not going to be at this point confounding what are load transfers with load increases or decreases in this case. So we'll do one last pass at this, just to illustrate what some of these settings done. So we're going to go through, and we'll leave the trend sensitivity as it is, because it seems sensitive enough. And what we're going to do here is we're going to loosen up the data shaving sensitivity. We're going to basically not shave as close to the loads, primarily so we can hopefully avoid dropping some of these values that are being picked up by the time trend, because the shavings identifying those as being outliers overall. And let's see what happens here. I'm going to load the input models. And subsequently clean the data, and then we'll look at the final results. Now, all of this analysis, again, is sequential, so whenever you change the inputs, you need to load the input models again and clean the data again if you change the underlying data or the underlying data cleaning inputs. So this will be our final pass, and after this, we'll probably move on to the next step. This process will be iterative, and there's a couple judgment calls. The default settings are going to capture most of the problems, and those are really setting the trend sensitivity of 5, the data shaving sensitivity of 5, and the number of flags for exclusion at 2. But in some cases, you want to modify those. And in some cases, you're going to be able to identify and say the algorithms don't pick up a few outliers that you may want to specify for exclusion directly. And we're nearly done. So this is giving us early preview, but it seems like we, in the final excluded versus not excluded charts, we reduced the number of observations that were excluded that likely should have been included. We had a few here before that were being excluded, and this looks like a satisfying result, and we likely can move forward with analysis. Here it goes. And we can confirm that we have relatively clean data at this point without too many errors of exclusion or inclusion. That the data points that we want to exclude are really data points that we likely want to exclude. And to reiterate, high level, you essentially have 4 levers to do the data cleaning. You have the trend sensitivity. The 2 more powerful ones are actually the shaving sensitivity or data cleaning sensitivity, and the number of flags for exclusions. If those don't capture or fix your issues, you can always identify periods to exclude by hand. You're going to have a whole bunch of charts that provide you feedback on the results and the reasons for why there's different exclusions. And if you really want to dive deep into the different issues, you can go to the Clean Data tab, and you can look at the data on an hourly basis and say, here's the reason why this specific period was excluded or kept in, and make an assessment in more detail. So that wraps it up, and from here we'll move on to the next step, which is analyzing the historical load patterns.